Okay, hi, this is experiment number 3, determination of the formula of a metal oxide. What we'll do is we'll heat some magnesium from a ribbon in air really hot, and from that we should be able to find its empirical formula. It might be MgO2, it might be Mg2O3. Depending on how much oxygen reacts with the magnesium, we should be able to figure out a mole ratio. A side reaction is the formation of a nitride. And that will happen, but we can convert that back to the oxide by simply heating it in hot water, letting the steam come off, and will convert any nitride that happens to form back into the oxide and should help give us good results. For the procedure, we're going to follow steps 113. I have it in front of me, and I'm going to walk us through it, even though you can't see it on the screen. But if you have your lab notebook, you should have a look at this, and we'll go ahead and go through this as I did. As we do, I'll give you some handy tips that should help out. What you start doing, let's give an overall view. You take a crucible with nothing in it, and we need to get it bone dry. So we heat it like ridiculously. We heat it for, I believe it's as much as 20 minutes, which is a long time. And then we let it cool. We put it down on the top right there. And once it's cool, you can handle it with your bare hands, so be careful. Most of the burns are from hot crucible, not the flame itself. Weigh it. Do the same thing again. I believe we heat it up for the same amount of time. And then weigh it again. And if it's within 5 milligrams, 0.005 grams, then we're good. If not, you have to repeat it a third time. What we're trying to do is just get a constant weight and be sure the thing is bone dry. Once you've accomplished that, we're going to now, coil a magnesium strip and put it in there. When you do that, don't coil it so tight that it insulates itself. Make it a little bit loose, but small enough that it fits on the very bottom right there of the crucible. And then we heat it for an extended period of time where it will form the oxide. We'll be adding some water after a while and then heating it again to turn any nitride back into oxide, get it bone dry, and then we'll weigh how much product we got, and it should get heavier, right? It's turning from magnesium into a magnesium oxide. Exactly how much heavier it gets, since that mass is all due to oxygen, should give us the gram ratio of magnesium to oxygen, and very importantly, the mole ratio of magnesium to oxygen. And it is the number of molecules, or the mole ratio, which determines the actual formula, whether it's MgO, MgO2, etc. Let's take a look at these little hints. If you see some white fumes escaping, cover it immediately, because that would be some oxide product that you don't want to lose. Once the things are cool, you can handle it with your bare hands. We find it's easier to do that. People keep dropping the stuff with the tongs because it's a little hard to handle things with the tongs. And here's the calculations that we'd like. 4 and 4 only. 1, the percent magnesium and oxygen in the magnesium oxide by mass. Number 2, the mole ratio, the number of moles of magnesium and oxygen in magnesium. And third, the theoretical yield, I spelled yield wrong there, of magnesium oxide, whether it's 80% or whatever. The theoretical yield would be in grams. The percent yield by percent, how close you came to that theoretical yield. It would be based on how much magnesium you started with. Excuse me. And note that it's easy to lose points in the calculations. We had some serious errors in the calculations last time, so for each calculation, please show me 1, an equation or a formula that you're going to use to solve each of these 4 calculations, and then do what they call plug-in. Solve that formula, but don't just write numbers. Include units with the numbers, make sure they cancel, and gives you a reasonable number. You will be graded on the accuracy of your results, and so try to make sure that these things make sense. Try to make sure that your formula for magnesium oxide is logical. And please don't forget to do the 5-point post-lab questions. Okay, that's it. I hope you enjoy the lab, and I'll see you tonight at 6:30.